from UF Studios. It's Saturday
Hi! In this video, we are going to explore the biomass facilities in the context of air pollution. By the end, we hope that you will be able to answer some key questions about them.
What is a biomass facility? How does it function? And how do they control any air pollutants they've made? What are the potential environmental and health effects? How does the government regulate these facilities?
Biomass is organic material that comes from plants and animals, which is used for energy.
Humans have been harnessing energy from biomass for years, and while there are many different types of biomass that we can use in modern times, we're going to focus on wood and pulp feedstock in this video.
Let's step through the direct combustion process used to harness usable energy from wood. First, trees are harvested, or wood debris is collected. It is transported to the facility where it typically undergoes a pre-processing step. It may be size reduced or dried to reduce moisture content. From there, it is stored or fed directly to the furnace. Here it is combusted, heating water in the boiler. When the water reaches a sufficiently high temperature, it turns into steam, which is channeled into a turbine. This generates electricity.
If we step back to the incinerator, we can see that there are some residual gases called flue gases leaving the chamber. We are going to take you on that journey right now. Okay, so let's first take a look at the chemical transformations taking place during combustion. This is a generic combustion reaction. We can see that one of the gases produced is CO2. However, the fuel burned at a biomass facility is much more chemically complex than the simple sugar I have written here. And this was assuming a complete reaction in the presence of pure oxygen. In reality, other elements and molecules are present in the wood. It is combusted in air, and some molecules undergo thermal decomposition. All of this is to say, wood combustion can also emit these other molecules. Carbon monoxide, carbon dioxide, nitrogen oxides, particulate matter, polycyclic aromatic hydrocarbons, and volatile organic compounds. Also to add, sulfur oxides. So, once in the atmosphere, some of these chemicals may react to form secondary chemicals such as ozone.
These chemicals, if emitted and present in high concentrations, are considered air pollutants. They have some negative health effects listed here. Did you catch that? Lol, JK, let's go over them one by one. Carbon dioxide is not intrinsically an air pollutant. However, the concentrations humans are producing and emitting CO2 is contributing to an intensified greenhouse gas effect. This is causing accelerated global climate change, which has far-reaching detrimental effects for both humans and the environment. Carbon monoxide is a precursor compound in tropospheric ozone formation, which we'll be going over in a few minutes. Particulate matter can cause a wide array of heart and lung diseases, including heart attacks, irregular heartbeat, aggravated asthma, decreased lung function, irritation of the airways, coughing, or difficulty breathing, and even premature death. In the environment, it negatively affects aesthetics by reducing visibility. VOCs are another precursor chemical to ozone. PAHs cause irritation of the eyes and breathing passages and some forms of cancer. Finally, we're at ozone. It has numerous human health effects, including reduced lung function and irritation of the respiratory system, premature death, asthma, bronchitis, heart attack, and other cardiopulmonary problems.
With chemicals this harmful, the US EPA must be working daily to regulate emissions, right? Well, the government does impose some restrictions on emissions, at least as of this recording.
According to EPA standards, the air pollution limits regarding electric steam generating units cannot exceed 0.14 pounds of particulate matter per megawatt hour generated, 1.4 pounds per megawatt hour for SOx, 1.6 pounds per megawatt hour for NOx, and 1.1 pounds per megawatt hour for carbon monoxide. As for moving away from the fossil fuels and towards renewable energy, the EPA requires at least 7.5% of all energy used by the federal government to come from renewable sources. In 2015, this was going to change to 30%, but somebody had to go and trump this new rule.
Oh, this coal. This is the best coal. Believe me, it's going to be fired.
Let's head back to the biomass facility. Each biomass facility will have air pollution control devices in place to ensure that it meets those government regulations. These controls will vary in type and sequence at each plant depending on specific fuel characteristics. However, at a wood combustion facility, you are likely to see these. This device is the baghouse. The baghouse is a chamber with a large number of fabric bags that sieve out particulate matter from the flue gas. Next, we have the selective catalytic converter, or SCR for short. This is a chamber with a complex honeycomb structure coated with a ceramic like titanium dioxide and catalysts like vanadium pentoxide and tungsten oxides. Then ammonia is injected into the chamber, acting as a reducing agent and converts NOx to nitrogen gas. And finally, this is the dry scrubber. It eliminates SO2 from the flue gas using dry natural sodium bicarbonate to form sodium sulfate, a solid residual.